In this example, we're given a circuit with some mesh currents and some constrained currents defined, and we're given some partial equations here and here. We were also given some missing terms. We want to find what those missing terms are in these equations. So first, let's look at KVL around mesh current I1. If I start down here, I get 3 ohms multiplied by I1. That implies that the sign convention is in this direction on the voltage across the 3 ohm resistor. I1 is entering the positive terminal. Likewise, for the 4 ohm resistor, it's positive 4 ohms times I1. That means that I1's entering the positive terminal, so that's my sign convention, minus I2, so I2 is entering the negative terminal. That's all consistent. Now we have to fill in this missing term. That's the voltage across this 8 ohm resistor. It's a positive contribution. If it's positive, that means that it's agreeing with this sign convention where I1 enters this positive voltage terminal. So this term is going to be 8 ohms times a positive I1, and the 6 amp constrained loop is also entering the positive terminal, so that becomes plus 6 amps. Now let's take a look at mesh current I3. That's this one. It's going in this direction. We're given the term that's the voltage across the 2 ohm resistor. So this term is positive. That means that I3 is entering the positive terminal. So that gives me a sign convention that positive terms if I3 is entering. The only other resistor is this 5 ohm resistor, so this term must be associated with the 5 ohm resistance. However, this term is being subtracted. That means that I have to set up my sign convention such that I3 is entering the negative terminal. So this voltage is 5 ohms, the resistance, times the negative of I3. Then I2 is entering the positive terminal, so that becomes a positive I2, and the 6 amp source is entering the positive terminal. That becomes a positive 6 amps. So if I plug this in for this negative term will be consistent.